This is the 10.3 independent practice. This is page 281. The directions say, for each expression, use a property to write an equivalent expression. Tell which property you used. So the first line will write an equivalent property, and the second line we'll talk about that we'll name the property. And if you're thinking to yourself, what properties are they referring to? I'm going to go back to a couple pages where we have our list of properties. It's on page 277. And these are the properties right here. Writing equivalent expressions using properties. These are all the properties. And the names of them, these are the ones I'm going to use. The commutative property of addition, commutative property of multiplication, the associative property of addition, associative property of multiplication, distributive property, and there's more. So I'm going to go back to our page, and those are the properties we're using, and I'll explain them as we go. So the first one is C times D. And what we need to do is write something that would be equivalent to that. Well, I know that if you just change the order of a multiplication problem, it doesn't change the value. So C times D would be the same thing as D times C. And that is called the commutative property of multiplication. Number 11 is very similar. I know that when you add x plus 13, you get the same thing as if you add 13 plus x. And that's the same property, except it's still called the commutative, but it's not called the commutative property of multiplication. It's called the commutative property of addition. That's it. It's the same property. Let's go back to 10. On 10, if you do, instead of C times D, if you do D times C, that's multiplication, so it's commutative property of multiplication. On 11, instead of x plus 13, you're going to do 13 plus x. That's the commutative property of addition. Okay, number 12 is a totally different property, and I hope by now, we've done a few of these, I hope by now you can recognize this one's the distributive property. So I'm going to write the property in right here, distributive property. And the distributive property is when you take the number outside the parentheses and you multiply it by everything inside the parentheses. 4 times 2 is 8 with an x. It's 8x. And then 4 times 3 is 12. And there is no x. And then we got to put this subtraction sign in between. It's real simple. That's it. That's all you have to do for number 12. And then number 13 is, this is the one where you can change the grouping symbols. And those are called the associative properties. So the associative property states that you can change the grouping symbols, but it won't change the answer. If I do a plus b and then add that to 2, or if I do 2 plus a and then add that to b, you get the same answer. So what I'm going to do is I'm going to write 2 plus a plus b all in the same order, but I'm going to take the grouping symbols that were around a and b. I'm going to move them out to be around 2 and a, and that's called the associative property of addition. If you need more help on those, go back and review the properties, or you can just watch this part of the video a second time. All right, let's move on. Number 14 says, draw algebra tile models to prove that 4 plus 8x and 4 parentheses 2x plus 1 are equivalent. I want to remind you that the x's are the long ones, so I'm going to put maybe I'll do a key over here. I want to remind you that these are going to be the x's and these are going to be the singles. So if you're like, what do you mean by that? Well, I'll draw an arrow just for a quick second. These are the ones that say x, and these are the ones that just have that right there. So what would these look like? Well, the first one is 4 of these guys. So I'm going to do 1. I'm going to draw this a little neater. 1, 2, 3, 4, and then I've got 8 of the bigger ones. 1, 2, 3, 4, 5, 6, 7, and 8. And so this would be 4 plus 8x. Now the second one we want to do is we want to draw just this first. So I'm going to draw just that first, and that's going to look like 2 of these. 1, 2, and I'm going to draw a line here and change color and draw a line. And this picture over here is going to be 4 parentheses 2x plus 1. So I drew my 2x's, now I need to add 1 to it. Maybe I'll put the 1 right here. And then the pictures don't look the same right now. Just remember that the 4 outside the parentheses means you need to do this times 4. So if I do this picture times 4, then I need another one of these pictures. 1, 2, and 1. And another one. 1, 2, and 1. And then one more. 1, 2, and 1. So now if you just count them up, you've got 1, 2, 3, 4 of the little ones, and 1, 2, 3, 4, 5, 6, 7, 8 of the big ones. 1, 2, 3, 4 of the little ones. 1, 2, 3, 4, 5, 6, 7, 8 of the big ones. So they are indeed equal. And that should make sense, because if I applied this 4 times 2x, what is 4 times 2x? It's 8x. And then what's 4 times 1 is 4. 8x plus 4 is the same thing as 4 plus 8x. All right, good job. Let's move on. Numbers 15 through 24 say combine like terms, and some of these are really pretty simple. Do you notice on number 15 that we've got the same x to the 4 and x to the 4? That means we simply do 7 minus 5 is 2, and then we write the unit x to the 4th power. It's that simple. All you had to do was 7 minus 5. Same thing for number 16. Do you notice we've got y and y? That means you add up 32 plus 5 is 37 y. Those are pretty simple. They're not all quite that simple. Number 17, do you notice that we've got 6b and 7b, which means we get to add those up. We don't then get to subtract 10 because there's no b there. So 6b and 7b is 13b, and then we subtract 10. And the reason why we can't subtract 10 is because I can't subtract 10 from 13b. They have to be the same variable. Number 18, I've got 2x and 3x, but I can't add the 4. So 2x plus 3x is 5x plus 4. Okay, number 19, this is where they kind of get just a little bit complicated. Before you do number 19, you need to do the distributive property here, and you need to do 3 times y. 3 times y is 3y. And you need to do 3 times 2, which is 6. Now you can combine your y and your 3y. What's 1y plus 3y? That's 4y's. And you can combine your 4 and your 6. That's 10. So we've got 4y plus 10. If these start to get complicated, feel free to watch any portion of these videos a second time. So number 20, I've got a squared is my variable. I've got 7 minus nothing, but the nothing is actually a 1. 7a squared minus 1a squared would be 6a squared plus 16. You can't add 16 because it's not an a squared. You can only add up when they have like terms. All right, so we've got another one here, number 21, where I need to do the distributive property. I'm going to do 3 times 4 is 12, y squared, and 3 times 2 is 6, and then that gets subtracted because of this sign right here. Now what can I combine? I've got y squareds and y squareds. So 3 plus 12 is 15. Y squared minus 6. Number 22. I've got a z to the third, which I don't have any other z to the third, so I can't combine that with anything. So it's going to be 4 z to the third power. I've got some z squareds. I can combine those. Again, this is 1 and this is 4, so it's a total of 5z squareds. Mr. Smith, how come you can't add up the 4 and the 5? Because you can't add up z to the third to the z to the second. They have to be the same variable to the same power. And then you have a z here that's not squared or to the third. And let's see if I took care of everything. I took care of that one. I combined that with that, and I used that one already, and I used that one already, so I got them all. That's the answer. 4 z to the third power plus 5z squared plus just a regular old z. Starting to get kind of complicated, aren't they? All right, number 23. This one's kind of brutal. That's okay. Be happy to help you. 0.5 means a half. So the very first thing I'm going to do is multiply, and we could change it to a fraction, or we can just leave it as a decimal. I'm going to multiply 0.5 times x, and you can't actually do that, so it's just 0.5 x to the 4th power. And then I can multiply 0.5 times 3, and that means half. Half of 3 is 1.5. So I'm going to do minus, because there's a minus sign right there, minus 1.5 or 1.5 plus 12. Now I can actually do 12 and 1.5, but it's going to be 12 minus 1.5. I know it's written out of order there, but if you subtract 1.5 from 12, you get 10.5. And that's a positive number, so that's plus, and then 0.5 x to the 4th power. That one is definitely getting pretty tricky. I would say you don't totally need to understand that one. That one's starting to introduce some concepts there that we're not super good at. Okay, a fourth of 16 is just 4. And a fourth of 4 is 1, so it's 1p. And so it's just 4 plus 1p. Or you could write that as 4 plus p. Or you could write it in any order you want. 4 plus 1p or just 4 plus p. All right, a couple more word problems and then we'll be done with this page. Good job. Number 25, justify reasoning. Determine whether 3x plus 12 plus x is equivalent to 4 parentheses 3 plus x. Use properties to justify your answer. Here's how we can do this. 4 parentheses 3 plus x is really easy to deal with. We simply multiply 4 times everything inside the parentheses. 4 times 3 is 12, and 4 times x is 4x. Is this equal to this? 3x plus 12 plus x. And the answer it is, because if I take this x right here and I added it to this, what would I have? I would get 4x. So what I'm going to do here is I'm going to rewrite this as 4x plus 12. And the answer is yes. It says use properties of operations to justify your answer. Here's why. Here's the two properties we used. This is the distributive property over here. The distributive property is this statement right here. And then this right here is the commutative property of addition. Commutative property of addition. Now I know that's kind of a mess, but whatever, it's not too bad. We use the distributive property to prove that 4 parentheses 3 plus x is equal to 12 plus 4x. And then we used the commutative property to say that 12 plus 4x is equal to 4x plus 12. The answer is yes. They are equivalent, and I already stated my properties. All right, number 26 reads, William earns $13 an hour working at a movie theater. Last week he worked 8 hours at the concession stand and 3 times as many hours at the ticket counter. Write and simplify an expression for the amount of money William earned last week. So he makes $13 an hour working at a movie theater. He worked 8 hours at the concession stand. So that's just 13 times h. Does that make sense? He makes $13 an hour and he worked 8 hours. So that's 13 times h. And then he worked 3 times that many hours at the ticket counter. That would be 13 times 3h. Now why is it 3h? Because it says 3 times as many hours at the ticket counter. And then, to figure that all out, you'd have to add them up. And what can we do here? Well, we can't actually solve because we don't know how many hours he worked. But what we can do is multiply 13 times 3 and we get 39. And now what we can do is we can add up 39 and 13. 39 plus 13 is 52h. And so what we actually learned here is not exactly how much he made, but what we learn here is that he worked 52 hours. I'm sorry. So when you combine the 13h, where he worked at the concession stand, and the 39h, because it's 3 times as many hours at the ticket counter, you get a total of 52 times h, and that's going to be the amount of money that he would have earned last week. Okay, good job. You're done with page 281.